Okay, so today we want to talk about how in a chemistry lab we would actually make solutions. And there are two main ways we can make solutions. And one of them is starting from a solid. All right, thank you. One of them is starting from a solid, where we take a scale and we weigh a solid, and then we dissolve that solid. And the other one is from diluting an already existing concentrated liquid. Now, a standard solution is a solution that we've taken great care to measure our solid, try to eliminate as many errors as possible, making sure the scale is functioning properly, making sure that we have proper type of weigh paper so that nothing sticks to it, or maybe some an aluminum boat or something like that. Perhaps we can put the solid directly into a beaker. And then dissolve that solid in a very well-known volume of liquid. And if we've done all of our jobs and we've done it very well, then we've created what we call a standard solution. It is a solution of well-known concentration. And when I say precise, the term precise indicates the number of significant digits. And if we've used very precise measuring devices, then we will get a concentration that has a lot of significant digits. And that's important. That means we know it to those digits. Weighing a solid and getting its mass very precisely, that's only dependent on how much money you want to spend on the scale. I may have indicated to you when we were talking about scales and significant digits earlier on, if you want to spend $10,000 on a scale, you can get a scale that'll read 4 and 5 decimals. 4 and 5 decimals. It's got to be in a little space that's closed so nobody else is in the room and the wind doesn't do anything. It's got to be isolated from vehicles driving by so that it doesn't cause the pan to wiggle and jiggle, but you can do it. You can get very precise masses. That's a little overboard for what we do, but you can. When it comes to measuring precise volumes, we use something called volumetric flasks. Yeah, volumetric flasks. That's exactly what I was going to say. It's cool. So here I've got a handful of volumetric flasks. They come in various sizes, and you use those different sizes depending on what you want to make, all right? But all volumetric flasks have this particular feature, and then they've got this large bulb on the bottom, and then the top is made up of a skinnier tube. And that's because if we want to get a volume very precisely, we want it to be in a skinny tube where we determine where we're going to stop, because any tiny little volume addition in that skinny little tube will cause the level to rise very quickly. So as we come to this point, the level rises very quickly. We slow down, we add maybe with a beaker and then with a dropper, and on all volumetric flasks, there will be a little line that indicates where to stop adding. And I'm actually just clicking my nail. It's an etched line in this case. So I fill it so the bottom of the meniscus is on that line, and I know that I have 2,000 milliliters plus or minus 0.5 of a milliliter. So this is known exactly to the last milliliter, if I get it on the line. So I might have 2,000.5, or I might have 1,999.5, but in the end, it'll round back to 2,000, unless I'm right on the 0.5 with 2,000.5. You get the idea. But I know this to 2,000, 4 significant digits. If I'm making a large amount of solution that we use in the lab, I'm using something like this. This is a 500 milliliter volumetric flask. This is Marie in her room, in the back of her room. She actually has a run of pretty well every volumetric flask size that you can find. This one's 500, depending on what you want to make. This one's a 250, and we got these, we don't use them, but we got them donated, a 10 milliliter volumetric flask. a more accurate way than a graduated cylinder. So you'd put what you want to dissolve in there, you'd put it right up onto that line, and you've got 10 milliliters, and this one doesn't have the plus or minus on it. I would have to check the Kinmax people of the United States to check what their error is on that particular thing. But it's probably 10.0, I would think, because of the diameter of this tube here. So we use volumetric flasks for getting very, very accurate volumes. And we use scales to get very, very accurate masses, okay? And if we know the concentration very accurately, then we have a standard solution. Don't write this down, but I'm hoping to show you the video here. I'm going to stop the recording and shut off my my microphone here just to kind of show it to you. But please make note of the textbook reference, and this is in the textbook. And I do sometimes on a test have a scenario where they're making a solution, and I ask you if they've made any mistakes in the procedure. I don't want you to write this all down right now, but definitely make reference to the textbook so that you can read through this. Okay? Now, I'm not going to read through this right now because I'm hoping my video will play and we can actually watch them use a volumetric flask correctly in determining this. So I've got to make my microphone stop, so we'll see if I can make this happen. I think if I maybe